Okay, so these are 2.2 notes. We're going to be graphing polynomial functions. So yesterday and the day before we were graphing quadratic functions, which were x squared. Polynomial is going to be more than x squared. So a couple of facts that we need to know about polynomial functions, that they are always continuous. So meaning that they don't have a gap in it. So for our first figure A, it's a polynomial function because it's continuous. Whereas the second one, B, is not a polynomial because it's not continuous. It has that gap, so that's what makes it not continuous. So to figure out if it's continuous or not, you can draw with a pencil without lifting the pencil from the paper for your whole graph. Another feature about a polynomial function is that it has only smooth, rounded turns. So it won't have any sharp edges. So it's smooth and rounded. So on the next slide, it says it cannot have a sharp turn, such as the one in the figure. So if your graph looks like this, it's not a polynomial because it cannot have sharp turns. This is what a sharp turn looks like. It'll be smooth and rounded, something like that. And then the graphs of polynomial functions of degree 1 are lines, so that's something like y equals mx plus b, because x doesn't have an exponent up there, so the degree would be 1. Something of degree 2 is a parabola, so that's like an x squared graph. Makes it a parabola. So the graphs of all polynomial functions are smooth and continuous. So they have to be both of these things. They will always be smooth and continuous. So a polynomial function of degree n has this form. So we're looking at the degree, which is the n. So in this, it'll call it n, which we're talking about the little degree. And n is going to be an integer greater than 0. So we won't have any like negative exponents or anything like that. No fractions with our x. So when n is even, the graph is similar to the graph of an x squared graph. So it's going to look like this kind of. So it'll have a parabola type of shape. Even x to the 4th power will still have a parabola type of shape. It'll do something a little bit more in the middle, but it'll have this type of shape. So it's similar to the graph of x squared. Or it could also be a sad face like this. So that's when it's even. When it's even, the arrows go in the same direction. So when n is even, when your exponent is even, the arrows go in the same direction. When n is odd, they go in opposite directions. And it's similar to the x cubed graph. So our graph could either look like this, if it's positive, or it would go the opposite way if it's negative, something like that. So it's similar to the x cubed graph. So both of these graphs are when our leading coefficient is positive. And then both of these graphs are when our leading coefficient is negative. So one way to think about it is when your leading coefficient is positive, the right arrow is going to go up. So your graph ends going upwards when it's positive. When your leading coefficient's negative, your graph will end going downwards. So in the negative direction. So it wants us to sketch the graph of negative x cubed. So we know our x cubed graph kind of looks like this. That would be the positive one. So our negative one has that same shape, but just goes in the opposite direction. We start going up and end going down. So that's our negative x cubed graph. We just flip the positive one. So it just goes in the opposite direction. The right arrow goes down. It ends going down because it is negative. What do you think is going to happen to my positive x cubed graph when I add 1 to the outside? Shift which way? Shift up 1. So when you add 1 to the outside, we go up 1. So instead of going through 0, 0, we're just going to go through 0, 1. It's the same shape, we just shift it upwards. And it's positive, so we keep the shape, the blue one, because it's positive. What about when we subtract 1 from the inside? It goes to the right one. So we're going to the right one. So it keeps that same shape, but instead of going through 0, 0, now we're going through 1, 0. We just shift our graph, the whole thing, to the right one. So these are just rough sketches of these 3 graphs. How could I make it more precise, more exact?
You can plug in x coordinates.
We can plug in x coordinates. You can plug in whatever you want for x and just plot those points on the graph, and it'll give you more of an exact graph. But this is just a rough estimate. And for graphing polynomials, we're just graphing rough estimates of our graph. All right, so this slide talks about it a little bit more. The leading coefficient test. So when n is odd, the end behaviors of our graph go in opposite directions. So opposite, odd is opposite. And in the middle here, it puts a dotted line because depending on what our graph looks like, depends on how many curves we have in there. So the middle part is kind of going to be what our estimated part is, but the end behavior is what we really care about. So when it's odd and the leading coefficient is positive, the right arrow is going to go up. So we call this falls to the left because the left one goes down, so it falls left and rises right. So this is when our leading coefficient is positive. When our leading coefficient is negative, it rises left and falls right. I think it's always helpful to draw the arrows of your end behavior first, and then just is your left arrow going up or down? So it's falls or rises. So just draw the arrows first, and then you can label it with falls left, rises right, or the other way. So this is when our leading coefficient is odd. Our degree is odd. The n is odd. So we're looking at the degree of x. If it's odd, they go in opposite directions. When n is even, they're going to go in the same direction. So they're either going to be both up or both down. So this one rises left and rises right. Or it would fall left and fall right. So this is when the leading coefficient is negative. It's going to go down and down, falls left and right. When the leading coefficient is positive, it goes up and up. right, so we have 4 examples on this page. So we're using the leading coefficient test to describe the right hand and left hand behavior of the graph. So I'm looking at my term with the highest degree. So we're looking at the negative x cubed. The rest of it doesn't matter. Now, is my degree even or odd? It's odd. So are they going to go in the same direction or opposite directions? Opposite directions. And is my leading coefficient positive or negative? Negative. So what's the right arrow going to do? Right arrow goes down because it's negative, and they go in opposite directions. So what does that mean the left one has to do? The left one goes up. So we would say rises left and falls right. All right, let's look at number 1 down below. Which term am I looking at here? The negative 3x to the 12th power, because that has the highest degree. So we always look at the one with the highest degree and we ignore the rest of it. So is my degree even or odd? It's even. So does that mean they're going to go in the same direction or opposite directions? Same. Is my leading coefficient positive or negative? Negative. So what do you think? Are they going to go up and up or down and down? Down and down, because they're negative. So the right one goes down, and they're going in the same direction, so that means the left one goes down too. So we could say it falls left and right. Looking at number 2, which term do I need to look at? Negative 5x to the 9th power. Is my degree even or odd? It's odd. So do they go in the same direction or opposite? Opposite directions. And is my leading coefficient positive or negative? Negative. So what's my right arrow going to do? Right arrow goes down, so what's my left one going to do? Left one goes up. If it's negative, the right one goes down. So like negative and positive determines the right arrow, and then whether they go in the same direction or opposite directions, you can, once you have the first arrow, the right one, then you can decide the second. So this one rises left and falls right. All right, for number 3, which term do I look at? Perfect. 5x to the 7th power. The rest of it doesn't matter because this one has the highest degree. So is my degree even or odd? It's odd. So do they go in the same direction or opposite? Opposite directions. And is my leading coefficient here positive or negative? It's positive. I crossed out the plus, but it was a plus. So this is positive. So what's my right arrow going to do? Right arrow goes up. What does my left arrow do? Goes down, because they go in opposite directions. So it falls to the left and rises right. So next we're going to look at the real zeros of polynomial functions. So when f is a polynomial function and a is a real number, the following statements are equivalent. So these all mean the same thing. A is going to be a zero of the function, a is a solution of the function, and it is an x-intercept. So it's where it crosses the x-axis. And factor pretty much means the same thing, just when you factor it, it's still written with the x in the parentheses. So like we factor a polynomial into the parentheses. So factor pretty much means the same thing, because once we factor it, then we can find the zeros. So when we find the zeros, we set y equal to 0, or f of x equal to 0. These are the same thing. And the reason why I underlined real twice is because yesterday you guys had a WebAssign, and sometimes you ended up with a negative under your square root. Let's say we had -4 under the square root. What did you notice about the graph when one of your zeros had a negative under the square root? Did it touch the x-axis? No. So this is not a real zero. So it doesn't cross the x-axis. It wouldn't be an x-intercept at that point. It's not a real solution. It's not a real zero. It is a solution. That's how we ended up with it as one of our answers, but it's just not a real solution, so it wouldn't cross the x-axis at that number because it's not a real number. So right now we're just focusing on real zeros. When we go later in this chapter, further on into chapter 2, we'll look at all zeros. So example 4, we're finding the real zeros of our function here. So we have x cubed minus x squared minus 2x. What do I need to do to find the real zeros here?
You can factor out n.
Awesome. I set this equal to 0, and I'm going to solve by factoring. So I can factor out an x. So when I take out an x, I'm left with x squared minus x minus 2. So I just divided all 3 of these by x. Put it on the outside. What can I do next?
You can factor.
How do I factor?
You find what multiplies to -2 and what adds to -1.
Perfect. We want to find factors of -2 that add to -1. So what would those two factors be? -2 and 1. Awesome. So in my parentheses here, I have x minus 2 and x plus 1. And then that x just stays on the outside. So I factored it, but now I need to solve. So I just set each one of these pieces equal to 0. So x gets equal to 0, x minus 2 I set equal to 0, and x plus 1 gets set equal to 0. And then I solve. So x is equal to 0 is already solved there. We're done. That's it. Then for the next piece, how would I solve for x? Add 2 to both sides, so x is equal to 2. And then in the third one, subtract 1. So x is equal to -1. So these are my 3 real zeros here. A little helpful hint is whatever your highest degree is, so here degree is 3, that's how many zeros you're going to have. That's how many zeros total we'll have. They might not always be all real zeros, but that's how many zeros we'll have. So the degree tells us the number of zeros or solutions. All right, just for fun, we're going to graph this too. So where my zeros are, that's where I cross the x-axis. So I cross the x-axis at 0. I cross the x-axis when x is 2. And I cross the x-axis when x is -1. Now looking at my highest degree, what's my end behavior of the graph going to be?
Falls to the left, right is to the right.
Perfect. It's odd, so they're going to go in opposite directions. And it's positive, so the right one goes up, the left one goes down. So out of my point farthest to the right, I have an arrow that goes up. And out of my point farthest to the left, I have an arrow that goes down. And then in between, we just have to make it a smooth, continuous graph. So something like this. All right, next, when we have repeated zeros, that's where we have multiplicity. So multiplicity is when one of our zeros repeats. If we have odd multiplicity, our graph crosses at that value. If we have even multiplicity, bless you, our graph touches and turns. So it'll just kind of bounce off the x-axis. So it touches and turns but does not cross the x-axis at that number. All right, example 8, we're going to sketch the graph of 3x to the 4th power minus 4x cubed. So what do I need to do to start to graph this? Do what? Factoring, so I can factor out an x cubed, perfect. I want to factor it, so I have x cubed as my GCF that I could take out. So I'd be left with what in the parentheses? 3x minus 4. So this is equal to 0. What can I do next? Set them both equal to 0. I factored it as much as I could, so now I just set both pieces equal to 0. So x to the 3rd power equals 0, and 3x minus 4 equals 0. So at x to the 3rd power, I have 3 x's here. So this means I have one x that's 0, another x that's 0, and another x that's 0. So I would have multiplicity here. Multiplicity of 3, because I have 3 of them, at 0. Or you could say at x is equal to 0. So since I have 3 x's here that equal 0, I have multiplicity of 3 at 0. Now I can solve my second piece here. So how would I solve the 3x minus 4 equals 0? Add 4 to both sides. So 3x is equal to 4. Divide by 3. So x is equal to 4/3. I only have one of those. So here I have multiplicity of 1 at x is equal to 4/3. So we said when we have odd multiplicity, our graph goes through that point. So what do you think at 0? Is my graph going to touch and turn or go through? What is 3? Is 3 even or odd? 3 is odd because it has a multiplicity of 3. 3 is the odd number. It goes through this point. So we go through 0. And then again, I have a multiplicity of 1 at 4/3. So do I go through or touch and turn? I go through because 1 is an odd number. So now I can graph. I'm going to put a point at 0 and another point at 4/3, which is like 1 and 1/3. So it'd be about here. We need to figure out the end behavior. So looking at 3x to the 4th power, it's even. So does that mean they go in the same direction or opposite? Same direction. Are they going to go up and up or down and down? Up and up because it's positive. So out of my point farthest to the right, I'm going to go up. Out of my point farthest to the left, I go up. Up and up. And then at both of these points, I go through the x-axis. So my graph looks something like this. This is a rough estimate. I think the exact graph does something funky like over here, but looks similar to this. All right, so we have 2 more examples where we're doing the same thing. So for the following equations, we want to find how many turns we have, which to find the turns, that's just n minus 1. What's our n for our first equation? 3. It's the highest degree, so that would be 3 minus 1, which is 2. So we have 2 turns. I don't think WebAssign ever asks you about turns, but it'll ask you about the rest of it. To find the end behavior, what do I need to look at? The highest exponent, is that even or odd? It's odd, so do they go in the same direction or opposite? Opposite, and is it positive or negative? Positive, so what's my right arrow going to do? right arrow goes up. What about the left one? Left one goes down because they go in opposite directions. So this falls left and rises right. Next, I want to find the zeros, or the x-intercepts. I mean, the same thing. How can I find the zeros here? I have to factor it. When I have 4 terms, how do I factor? By grouping. So I group the first 2, group the second 2. What can I take out of the first group? X squared. So take out an x squared, and I'm left with x plus 1. What can I take out of the second group? -4, and I'm left with x plus 1 again. What do I do next? I take out the x plus 1, and then what goes into my other group? X squared minus 4. So the ones on the outside go together. What do I do next? Set them both equal to 0. So I have x plus 1 equals 0, and x squared minus 4 equals 0. So here I can subtract 1 on both sides, so x is equal to -1. And then in the second one, I'm going to add 4. So x squared is equal to 4. What do I need to do next? Take the square root. What do I have to remember to do when I take the square root of both sides? Plus or minus. So what's the square root of 4? Plus or minus 2. So my zeros are x is equal to -1, 2, and -2. All right, now let's look at the multiplicity. How many -1s do I have? I have 1, so this would be multiplicity of 1 at x is equal to -1. What about at 2? How many 2's do I have? Just 1. So I have multiplicity of 1 at +2. And then what about -2? I have 1, so again I have multiplicity of 1 at -2. All right, and then lastly we have to figure out if it touches and turns or goes through the x-axis. So when my multiplicity is 1, does it touch and turn here or go through? It goes through. Through. Again, my multiplicity is 1 at 2. Does it touch and turn or go through? It goes through. Because we're looking at the number of multiplicity. So again, when my multiplicity is 1, does it touch and turn or go through? It goes through. So on the last page, it asks us to find a polynomial with the given zeros. So here it gives us the answer, but we have to come up with the polynomial. So we're just working backwards. So here's our answer. Now the next step would be these came from factors. So I'm going to put them back into factors. So when I put it into factors, I have to change the sign. Because if I go forward and I say x minus 3 equals 0, I add 3 to the other side, and that's how I get the +3. So when we put it into the factors, you have to change the signs. So what would my next factor be? X plus 4. And then lastly, we have x minus 1. Now again, going backwards. What do you think I have to do next? FOIL, yes. So to FOIL, I'm going to just FOIL the first 2. So just 2 at a time. So FOIL, we're going to multiply the x's. So this gives me x squared. The outsides would be plus 4x. The insides are minus 3x. And then the last ones are minus 12. Combine like terms. So this would be x squared plus x minus 12. And then I still have to multiply that times x minus 1. So I'm still foiling here. It's just an extra step because we have to make sure everything in the first parentheses gets multiplied to everything in the second. So I'm going to start with the x squared. X squared times x would be x cubed. X squared times negative 1 is negative x squared. Then I can move on to the x. So x times x would be x squared. X times negative 1 is negative x. Then I can move on to the negative 12. So negative 12 times x would be negative 12x. And negative 12 times negative 1 would be positive 12. And then last step is combine like terms. So I have x cubed. These two go together, so they actually cancel out. Perfect. Then the x's go together, so this would become negative 13x plus 12. And the very, very last step is that we have to name it with either a y equals or f of x equals. Have to name it. If you don't put this f of x equals, you'll get points off. For number 3, it's missing a 0 here, a factor. So it should also be negative square root 3. So it's just missing 1. But I want to do number 4 with you guys, just to take a look at it. So looking at number 4. We do the same steps, so I'm going to put them into my factors. So I have x minus 3 minus square root 2. Then I have x minus 3 plus square root 2. I'm going to put those in parentheses. And then I have x minus negative 6. So it's always x minus whatever your number is. Because that's how we change the signs. It's x minus, the signs get flipped. So what do you think I should do first here? Before I FOIL. I want to distribute that negative to both things on the inside. So my first parentheses becomes x minus 3 minus plus, because it's negative times a negative, so plus square root 2. And my second one becomes x minus 3 minus square root 2. And then I have x plus 6. You always want to start when we FOIL, if we have complex numbers, start by multiplying those together first. So we're going to start by multiplying our x minus 3 plus square root 2 and x minus 3 minus square root 2. So I'm going to show you the shortcut. I would normally do the long way and the shortcut, but just for the sake of time. My first term here, I'm going to say is x minus 3, because it's the same thing in both of these. So I have x minus 3 plus square root 2 and x minus 3 minus square root 2. What would these two things be called when they're the same, but the only difference is the sign in the middle? What do we call those? They're conjugates of each other. So does anybody know the shortcut when we have a plus b times a minus b? Does anybody know the shortcut? They end up getting canceled out, but what do we do with the rest of it? The whole thing doesn't get canceled out. So the shortcut, when you have conjugates being multiplied to each other, instead of foiling the whole thing out, it is a squared minus b squared. So our a would be this x minus 3 squared. So then minus our b, which is square root 2 squared. So if we wanted to, we could have treated this as just 3 separate terms, FOILed it all out. You'll end up with the same answer if you do it right, but this is the shortcut. So how would I do x minus 3 squared? I would have to FOIL, so it ends up being x squared minus 6x plus 9. And then what is the square root 2 squared? 2. The square root and the squared cancel, so it's minus 2. So this turns into x squared minus 6x plus 7, because I combine the like terms. And then I have to multiply it to my x plus 6.
So our last step would be to FOIL. It's a little bit more than FOILing just because we have 3 terms in the first one and 2 in the second, but we just make sure everything in the first set of parentheses gets multiplied to everything in the second. So starting with x squared, we have x squared times x, which would be x to the 3rd power. Then x squared times 6 would be 6x squared. Then we can move on to negative 6x. So negative 6x times x would be negative 6x squared. Negative 6x times 6 would be negative 36x. And then 7 times x would be 7x. And 7 times 6 is 42. And then we just combine like terms from here. So I start with my x to the 3rd power. And then 6x squared minus 6x squared end up canceling each other out. And then I have 36x minus 7x. So that would be minus 29x. And then plus 42. So we will practice more of these on Monday, as well as the last example we skipped from the page before.